Good morning, everybody. Welcome to lesson 3 of Surf's Up Waves All Day curriculum. Today we're going to be talking about sound waves. And I have this up because I thought this would be a good way to start the class with students. And so normally when I start the class, I have this up and I say, what are we looking at here? And kids are hyper online now, so they know what a sound wave is typically, and so they say sound waves, and they're right. And so this tool here is called the virtual oscilloscope. We talked a bit about oscilloscopes in the last lesson. This is a virtual one that can use your live input, which is your microphone. It's got a few options here. This one is kind of helpful, especially if you have a quiet classroom or your microphone is far away from where you're talking. You can always increase the gain. The gain basically increases the amplitude, so it makes it a bit more wilder. So like small changes end up really big. If you make it too much, it'll go extra wild. Or you can make it really tiny so that it doesn't pick up very many signals at all. Or it picks them up, but it doesn't display them very high. So this is just a scaler here. There's other options too, but I wouldn't worry about that too much. Whoops, not where I wanted to go. So welcome to lesson 3. I'm Gaelen, and today we're going to be talking about sound waves. So we already looked at the virtual oscilloscope. So we asked kids what they're seeing right now, and part of the idea of this lesson is that they're seeing the representation of sound waves. So they're seeing data representation. They're not seeing the sound waves. We don't see sound waves, we hear sound waves. These are waveforms, which is the digital representation, or I guess in some cases it's analog, but it's a visual representation of a sound wave. And so we're looking at waveforms. And waveforms are computer representations of sound waves. And like most of the lessons, we go into a bit of natural science first. So we're going to look at other animals. Most creatures have a way of communicating. I'm sorry if I did this slide in another presentation. I forget in another presentation for this unit. I forget if this shows up again or not. But this is a great way for kids to share out animal facts about different ways animals communicate. Birds communicate through tweets and songs. They also do dances. Birds communicate with dances. There's lots of cool documentaries in the last few years about bird dances. Dogs communicate, maybe kids might say barking or smelling. Dogs are always sniffing each other. So they have other ways of communicating. Whales, they communicate through audio as well, and they make nice whale noises. Something that I learned about during the pandemic was that because early on during the pandemic, there's less humans in the ocean, especially along like beaches and stuff like that. And so it was a lot quieter outside. And whales, their children, they let their children go much further away because now the whale, I don't know what the word is to describe the whales, sort of like sonic trumpet that it kind of sends out. Trumpet's not a good sound for it. But the whales were able to let their offspring go further away from them because their sounds were able to travel further, so they could talk to these to their babies and their kids from much further away because they explored the whole ocean, and so they weren't as constrained. They didn't have to be so close to each other because there weren't people and boats and stuff like that taking up the water and sending noise pollution into their environment. Ants communicate not by sound but by pheromones, which are chemicals, which are smells. So ants are really good at picking up different they have chemical receptors for picking up different smells and scents, which in scientific sense we call them pheromones. So that's how they would communicate. But how do people communicate? Most people talk, but communicating is more than talking. We also need to listen. And people communicate in different languages as well. Maybe listening isn't enough because they're in a language that we don't understand. Not everyone talks and not everyone can hear, so it's important to bring that up in the class, that there are differences out there. And we're going to bring that up in a moment, but I'm going to diverge for a moment. So what are we really doing when we're talking and listening? When we talk, our larynx, again, I try to bring science in when I do this with kids and talk about body parts. Our larynx, tongue, and lips work together to create sound waves. My son is in speech therapy, where he does a lot of, especially early on, they talk a lot about the tongue and the lips. And so it's nice for kids to kind of like learn about these things and what goes on into speaking. And so those three body parts work together with our lungs to push air out, and it creates vibrations in the air pressure. And so sound waves come flying out of our mouth through the air. And as they travel through the air, they kind of dissipate. The vibrations go away. But our ear picks up on it. So our ears capture those vibrations. Some animals have bigger ears. Some people have bigger ears. And they capture those sound waves. And inside of our ear, sound waves go in, and there's an area called there's a part called the cochlea. And if we zoom in, actually this picture's not a good picture for it, but a cochlea is this little snail looking thing. And it basically has little hairs in it that tickle parts of the brain. That's a good way, that's how I always describe it to kids. There's little hairs that tickle parts of the brain, and those little tickling things are what are basically converting sound waves into brain waves. Is that it tickles our brain, it takes those sound waves, those air vibrations, and turns them into electrical, or not electrical, chemoelectrical signals in our brain. That part's not important, the chemoelectrical part. But this is important because you might have students in your class with cochlear implants. And so this is the cochlea. This is the part that's getting implanted. This is the thing that's gets modified when kids have cochlear implants. And it's because, actually I'm not really sure why, if I'm remembering right, it's because basically the tickling part isn't really working right. There's something with the hairs. I'm not entirely sure, so I don't want to speak to that too much. But I do know that that is the part that gets modified. And here is a picture of how that modification works. So it's got when you have a cochlear implant, there's a few different parts to it. The part you see on the outside is a microphone, an input, and it's got a speech processor, which does like, the speech processor basically looks at the sounds and looks at what sounds are worth amplifying or not amplifying. So it's kind of like if you've got like fancier headphones that do noise cancellation, the speech processor does the noise cancellation for them. So they're not hearing like motorcycles go by, or they're not picking up every sound. It's kind of it's reducing the noise that it hears, so it just focuses on the things that should be important. So the speech processor then sends it to this receiver here that's been implanted in them, and that sends it down to the cochlear implant, which is down here. And there's a little electrode array that goes inside their cochlea. And I'm going to show you a picture of this in probably like 15 slides when we talk about special equipment. But it's an electrode array, and that takes the place of the hairs, and it uses electrodes to use electricity to stimulate the parts of the brain that are responsible for sound. And it's great to talk about this because I don't know, I feel like in every school I have students with cochlear implants, so it's good to normalize it, let kids know that there's this cool thing going on in some kids' brains where they're cyborgs basically. They've got computer parts in them to listen differently, and it's kind of cool. Anyway, so lungs, larynx, tongue, lips work together to create vibrations in the air pressure. They get picked up by our ears. And so when we're talking and listening, it's really about sound waves and vibrating air. And that's true for us talking, but also for speakers. So if you've got a speaker in your classroom, kids can go up and touch it, and you can feel the vibrations when the sounds are coming out. You feel the vibrations of a speaker. There's also cool projects you can make where you can make a speaker with like a paper plate and some magnets and some coil. It requires a bit more tools than I think most people want to use, but it is something you can do in a classroom. If you look up paper plate speaker, something more likely a science teacher would do because they would have readily available access to those kind of supplies required for it: magnet, wire, and paper plates. All right, again, we want to talk about other ways people can communicate. People communicate with sign language. People can communicate through reading and writing, visually, through painting, through video. So there's other ways to communicate. And so sound isn't the end all and be all of communicating, but it is a way that most mammals communicate in some form this way. But there are other ways to communicate. Okay. So now we're going to look at visualizing sounds. When I do these lessons in the class, I try to make a game out of it. We try to make a game out of it. And so we start by trying to get them to visualize, see how sound waves can represent what a sound is. So we show them the sound wave and we go, what do you think's happening here? And let's hope this isn't too loud. Here we've got a waveform for firecrackers. A lot of these sounds are based off of Lunar New Year because we did some of these lessons around Lunar New Year. And so the idea for this, the purpose of these slides are to see like how the sound affects the waveform. So this has got a lot of loud sounds, so the waveform is going up high. It's got a high amplitude, and it's pretty consistent across, which means there's lots of loud sounds happening. And here's another one. We got bubble wrap, and so there's some little sounds that happen sporadically. But they are a little loud when they happen. Here's one, pop rocks. And so pop rocks are tiny little sounds, little pops, but there are a lot of them. And so you see lots of little waves here while it's popping. Here we have a fireplace. So for the fireplace, there's not a lot of sounds, but there are some loud pops as the wood pops. And then we have some cereal. Rice Krispies, Snap, Crackle, Pop. And in this one, it's very quiet, so you see very little sound wave action going on. And we have one more, a popper. I forget what these are called. These are really fun, though. So this is going to have one loud sound. When we did this lesson a couple times in class, this coincided with Lunar New Year. So the activity for this, which I'm not going to go over today, was creating a confetti popper that was made out of like a toilet paper tube and a balloon cut in half, so you could shoot confetti in the air. That doesn't really work well with the lesson we're doing, but if anyone out there wants to do that one day, they can. Just some ideas out there. Okay, so another way you can approach this, or in addition, not another way, but you could do this in addition to how they're learning about waveforms and sound waves, is by getting some sound waves. I'll show you how to get images for the waveforms later. And then they have to match them up. And so this is like a music class edition of it. If you've got, so you can talk about different, train whistle's not really a musical instrument, but everything else is. So we've got accordion, train whistle, bell, tambourine, maracas, and glockenspiel. And so then the kids have to match up. We're not going to play the sounds. They only can look at the waveforms and decide which one it is. And so in my presentation here, I feel like an accordion is like, so that might be, they're kind of loud. So this one might be the accordion. Maracas, maybe this one because it's a bit rhythmic. But this looks like a quick sound because it's a lot of things repeated quickly. But maybe that's the maracas. A bell is going to be ding. So a bell probably only has one loud sound and it gets quiet. So I bet number 1 is the bell. Glockenspiel or xylophone. It's like dung 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 dung. I bet that's this one because it's got a bunch of different sounds probably. Tambourine. Ching. Maybe this one's tambourine, which leaves this one for the train whistle. Let's see if I was right. No. Let's see. Oh, I got bell right. I got pretty much every other one wrong. Anyway, let me put those back. I'll show you how to make your own sounds later, or your own waveforms from the sounds later, so that you can get images like this from sounds you want to use. Now we're going to get back to the tech side. Inputs and outputs. To recap, communication is about sending and receiving sounds. When we're sending sounds, we're acting as an output. We are putting things out there. So sending, output, creating sounds, talking, playing sounds on a speaker, those are all examples of output. When we're receiving sound with our ear, that's an example of an input. So our ear is an input. A microphone is an input. A microphone is an input. So speakers, output, microphone input. If you you can also show kids where your microphones are on your phone or on your computer. Let me grab my laptop here, hold on. If you look closely at a computer, does this one have it? Oh, my new one doesn't have it. Well, schools don't always have new tech. Whoops. If you've got the older, if you've got like a, I don't know, my new MacBook doesn't have the little holes on it. But if you look closely at your computer, oh, I have an old one right here. Let me grab that. Let's see, this one might have it. Oh, what happened to this computer? No, this doesn't have, oh, there it is. Okay. So, if you look along the side, you'll see these little, let's see if you can see it there. There's two little holes. And those are microphones on your laptop. As I see that, does this one have it? This one doesn't. Sometimes they're on the top, sometimes they're on the side. And that's why, like, sometimes if you're just like playing with your computer when you're in like a Zoom meeting and someone's like, I can't hear you anymore, and it's because your fingers are over the microphone hole. And you can also see those on phones. So if you flip over a phone or an iPad, you can see the little holes. They're always tiny little holes. It doesn't take much for a microphone. Microphones can pick up a lot more than I wish they did. I definitely know my kids' teachers have heard me yelling across my apartment when my kid's in a room with his door shut, and somehow they still hear it pretty clearly. So microphone technology is pretty good. Recording audio is very hard to get it right, but microphones, they sure do pick it up. Pick up lots of noise, lots of background conversation that I wish they didn't. Anyway, so the takeaway from one of the takeaways from this part of the this lesson is that we want kids to realize about inputs and outputs, and that speakers act as outputs, whether it's a computer speaker or our own voice, and microphones act as inputs. Our ears act as inputs. We're going to go back to a little bit more of the science side of things. So vibrations create sounds. Here's some different sounds, some different musical instruments that focus on vibrations. We can also hear some vibrations. We can hear, vibrations create sounds. We can hear some vibrations. We can hear cicadas, we can hear crickets, they're vibrating their legs, rubbing them together to make their sounds, and they can be pretty loud. But nature actually makes quite a bit of sounds that we don't hear. And so I wanted to play this little video. I'm just going to play a snippet of it, but there's the link to it is in the resources.
Plants face a number of threats from their environments, such as weather and insects. Now, University of Missouri researchers have found that plants can defend themselves from insect threats simply by hearing the threat. Using a special laser microphone, the MU scientists recorded the vibrations, or sounds, of caterpillars chewing on plant leaves. They then played those chewing sounds to plants before allowing caterpillars to eat the leaves of the plants.
What we found was that having been exposed to those vibrations.
Okay, so this video goes on to tell us they're using this cool laser microphone to measure the small sounds, and then they play these sounds back of a caterpillar eating the leaves. And when they play that audio back to the plants that haven't had caterpillars on it, they will react as though the caterpillar is on it. So basically it's talking about how even plants listen. They listen to vibrations. They feel them. They don't really listen. They feel the vibrations and they respond to it. And there's lots of sounds out there. I have other videos in the resources about listening to plants. There's a cool documentary. Yadira just saw it at Alamo Draft House about from the 1970s, The Secret Lives of Plants, I think is what it's called. And it's got a cool Stevie Wonder soundtrack to it. And it's basically about how plants respond to stimuli and they respond to sounds and they make sounds. It's really interesting to think about because I don't think we always think about plants as truly living creatures in the sense that they respond to stimuli. So it's an interesting way for kids to look at it. Plus the video's got the laser microphone in it and the oscilloscope to help show how scientists really use this technology to measure things. And the next lesson that we do, lesson 4, the reason why I bring up nature in this is because in lesson 4 we also use nature as a jumping off point where we talk about butterflies and caterpillars. So this ties in a bit if you bring up nature. So there's a bit of a tie in there. So we're going to talk a bit more about technology now. So some of the special tools used to hear these secret sounds is a piezo element. And it's another magic rock, sort of like silicone. Oh my God, I can't believe silicon. Sort of like silicon. And this magic rock uses crystals to turn vibrations into electrical waves. So it feels vibrations and then it can change its current. If it has electricity running through it, can change the current based on those vibrations. And so it is used, it can be used as an input or an output, which we often see. We'll see that in the next item too. So it can either turn current into a sound or turn sound into current, electrical waves. So it can go either way. It can work as an input or an output, but typically it's used as an input. It's used in electric guitars as pickups. So people make their own guitar pickups with it. As an output, that's as an input. As an output, it's used as like buzzers. So like if you fool around with Arduinos, you might get like a little a little buzzer piece, and that usually has a piezo in it that is getting electrical signal and vibrating really fast to make that buzzer sound. So it can go either way, but it's mostly used to turn sounds into as a piece of an amplifier, like a guitar pickup, to turn those vibrations into larger sound waves. And there's lots of projects. If you run like a maker club, it's pretty easy. I remember doing this years ago, where kids are making their own little guitar type instruments, making pickups, and it really only requires a little bit of soldering and having an amplifier to plug it into to make a pickup with a piezo element. And you can put it on all kinds of things. We actually use piezos in our classes when we do this, but I don't want to show you that because I don't think teachers are going to go through the hassle of that. But if you are a bit of a maker teacher, let me know, and I can show you how to do that. Another special tool is electrodes. Electrodes again can go either way, creating a signal or receiving a signal. Electrodes are very commonly used in medical equipment. So EEG, which is for measuring brain waves. Maybe you've had or seen like it's like a net that goes on your head, and they usually have like somewhere between 32 and 128 electrodes. Usually if you're getting like a medical exam, it's usually smaller on like maybe 32 or 64. If it's for research, they might have a big one that has 128 electrodes on it that cover all parts of your brain. And the electrodes are picking up small, very tiny electrical signals coming off of your brain, which is underneath your skin, which is underneath your skull. And so it's picking up very tiny electrical signals. And it's amplifying them so that the computer can measure them. That's what the electrodes do. They pick up tiny signals and amplify them, or they receive signals and they turn them into very tiny signals. So as an input, it's used in measuring brain waves for EEG, which perhaps if you have a student in your class who might have seizures, they may have had that done to them. They may have had their brain measured that way. It's also used as a way to listen in on plants and trees. So the electrodes can pick up the small electro signals that plants and trees create, and you can listen in on what plants and trees are doing using electrodes, which is what the picture over here on the one with the picture of the plant. I don't know if it's your left. It's on the left side of the screen. As I mentioned, it can also be used as an output, and we mentioned earlier cochlear implants. And so here is the piece that goes inside the cochlea, and so this is the implant. And you can see a few electrodes in there. And so they receive the electrical sound signal from the receiver and the microphone of the cochlear implant, and then they use these electrodes to stimulate the parts of the brain that are responsible for sound. And so it's creating little sound waves using electricity to excite and stimulate the brain, the sound processing part of the brain. And so this gets implanted and curled up into the cochlea. So now we're going to go over an activity. Misspelled generate there. Yeesh. Generate a new sound effect in chiptune or another tool. So getting back to the game side of this, we are going to use something in the resources called chiptune to create a sound effect. We don't need you anymore. So here's chiptune, which looks pretty complicated. It's like a full-on synthesizer, so it can like play sounds. And I would not recommend using it like this, like a musical instrument. Kids will have fun playing with it, and it'll be noisy in the classroom, and it'll be really exciting for everybody. There's little knobs you can change to kind of change the sounds. If you're a musician who fools around with electronic equipment, some of these will make sense, like attack, decay, sustain, release. These are all typical synthesizer functions. I can't get into all the stuff. I don't know all the stuff here. Last week I talked about different types of waveforms, how they have like square waves. So these are some different waveforms. We have a square wave. I think these are called sawtooth. These are typical sine waves. These are random RNG, not random number generated, but like just noise, just different types of noise patterns. But it has some predefined sounds here that when you click it, it makes different zap sounds. So each time you click it, it does a different kind of zap sound. And the kids can find one they like, and then they can start modifying it. Can increase it. So they can learn a little bit about how these knobs work by decay is basically like how long the sound lasts for. So they can make some different sounds, or maybe they want to try a different wave type. And so they can basically mess around with this. There's an equalizer over here to mess with it a bit. They can change the key that it's done in. Some kids that are more musically inclined might be really excited to have a keyboard here and like try different things that they know. You can always pick, just to point out, each time you click these, it generates a different one. And so you can, once you've done modifying it, you can save it. So sounds here are saved into wave format. We could talk about file formats here. Sorry, my picture wasn't up for a bit. We could talk about file formats here. So wave is like an uncompressed file, but these are short, so it doesn't have to be compressed. But MP3, wave, other formats are M4A or AAC. There's different file formats for audio files, but wave is like the raw format. So we're just going to click. We're going to click save. It's going to say, yeah, download that, and it's going to download my audio. So now I've got an audio file. Not going to play it yet. And we can bring it into Scratch if we want. This isn't a great activity for younger kids. Playing with the sounds is a great activity for the younger kids, but once you get to the exporting side of things, it's not a great activity, just because it requires a few steps that that younger grades are not going to be able to do. Upper grades, 4th and 5th grade, especially if they're used to using Scratch and stuff like that, they'll fly through this part. But I find that kids have a lot of difficulty understanding saving files and opening files, and just general file management. So that's something to consider here. As we're generating sounds. But younger kids can come in here and test out some sounds, and you can have like a little listening party at the end of class where everyone can play their sound. Whereas older kids can actually play and save their sounds. So once they've saved it, we're going to go to Scratch. Oops. And let's just create something new. All right, and we are going to go to sounds. They show waveforms here, which you can always use, and another activity where it shows the waveform. But we're going to choose a new sound, and we are going to upload one. Go to downloads, and my sound here that I just created. I'm going to rename it Crash. And now they can use Crash. They can make it fade in if they want. Be careful with, the kids will think this is undo, but it's not undo, it's just clicking the sound, which is cool. But these filters you apply to them, you have to undo them if you don't like them, and kids might have problems actually undoing it, especially if they walk away from the screen and come back to their sound. Now you can't undo it, which is frustrating, so you have to re-upload it. Whoops. So just, you don't want to warn the kids about messing with their sounds too much and then not being able to undo what they've done in Scratch, because you won't be able to undo it if you click off the sound. Just to show you that again, I do fade in, and then I click. I could undo it now and redo it, but if I click off, I can't undo it anymore, and I'm stuck with what I have. Anyway, that's how you upload a sound, and then you can, let me get my original sound back one more time. Whoops. Upload sound. Give it a name, Crash. And now if I want to use it, when I'm in the sound blocks, sound block will have my crash there. And so that's how you get the sound into Scratch for them to use. Let's leave that there, actually. Okay. What else we got? So I also mentioned here you can turn it into a yarn waveform if you're making a museum gallery, or you just want to have like in the extensions I mentioned, a wall of sound. Sound is a frustrating thing, I think, to work with in the classroom because you're going to have 25, 30 kids all playing sounds, which is annoying. Maybe annoying is not the right word, but it's loud and distracting. And it requires file formats. You can't save them. You can't print off a sound, except for creating the waveform, which I'm going to show you in a moment. But anyway, as a wrap up for the class, you can have a listening party. Students play their sound effects. And if it's younger kids, maybe the kids can guess what they might use the sound effect for in their game that they're making. But we want to come up with a way for younger kids to save their sounds. So I'm going to show you how to generate a waveform image in just a moment. Oh, that moment is right now. I thought this was further away. So you can use this website, which generates a waveform image from an audio file. And so you're going to upload your audio, download the image, print it out, and then decorate the image. And let's do that now. So we have the website. You do have to do some modifying, and this isn't something younger kids can really do. But maybe you can pick a couple sounds and do it for the class, or if there's groups, you can get their 5 sound files and do this for them so that they're prepped for the next week. So I'm going to pick my sound wave, and conversion is complete. It brings me here. It gives you some options. You can just change the color to black so that when it prints off, it's black. This gives you different options for the waveform size. I'm going to pick the largest one because I think this might amplify the same way we saw the scale change earlier. We want a large scale so that the wave gets really big, so there's a lot for the kids to do, and it saves you having to modify it later. But just let me take a look at what this does. Did this do what I am hoping? Okay. When you use the synthesizer, the sound waves look really, because it's a synthesizer, it's creating a lot of sound waves because it's using the way it's generating the sound in a synthesizer just really affects the sound waves. So you see these what looks like noise happening pretty much. Whereas if you record a sound with your voice, like if you're going to have kids like make sounds with their voices, like that will look much more like a wave. Like I have an example here of one that I did earlier. And it looks much more like a wave as opposed to this, which is like which looks pretty noisy. But you can download the file. Save link to downloads. And what I do when I'm doing these with students is I create a presentation. And I'm sorry, I don't use Google Presentation, which I know is frustrating for teachers because most teachers use it now, but I find it gets in the way of what I want to do so often. But you can probably do this in Google Presentation too. I'm going to import the image, and I want to modify the image, but I don't want it to stay proportionate. So I'm going to close the proportions there, and I'm just going to shrink this a little bit. Done, and then I'm just going to make it as tall as I can. You could add text to it if you want so that you know what it is. Crash, give it a little name. Use my cool Grand Standard font. And crash. All right, so this can be printed out and put on the wall. And once they print it out, whoops, you can't see my crash up there. There we go. It says crash. Anyway, once they print it out, there's some different things they can do with it. Oops. Print. And you'll notice that Scratch, by the way, let's open up Scratch again. I'm glad I did not close that window. Scratch, when you've got your sounds, you'll notice that the Scratch wave, it doesn't do the amplitude, it just sort of shows you the outline. And so you see same outline here if we were to outline this. Page is coming out right now. We'll get to our activity. Should be printing. What's wrong with you, printer? Am I out of paper? Okay, it should come out any moment. If it doesn't, I have my other printout here. Anyway, for this activity, you can use puff paint, glitter glue, or yarn, or all of them. You know, it depends how crafty you want to get. And come on, printer, print out my page. What the heck? Let's get the, nope, not that. Okay, so once you've printed out your page, I don't know if that page is ever going to come out. We have got, oops, no, that one, okay. We've got this waveform, and you could just have them decorate it. Fortunately, I could only find, I don't know, I think, well, my puff paint is white, which isn't going to really work on white paper. But you can do the outline of it. I would not have them fill it in, but you could have them fill it in. There's other ways to generate waveforms where it creates, you'll see this in like SoundCloud where it will have like lines. Oh, here it comes. Where we'll have lines instead of being filled in like this, it'll have like lines. Let me see if I can show you a picture of that. Hold on. Waveform. Generate. Hold on. Waveform from PNG. Give me a moment here. There we go, wave visual, okay. So this is another way to have waveforms. This website, you have to pay to download them, which is kind of annoying, but lets you create art. But one of them uses these lines. And so if you can imagine those lines, but using yarn for the lines, that's one way you could do this. Let me go get the one that printed out. Okay, so here we have crash, and depending on how much time you have, how much supplies you want to bring out, you can have the kids glue lines on here with the yarn. going to use my puff paint instead of glue here. Yesterday in class, we were making scratch and sniff stickers, and let me tell you, kids in their application of scented or of essential oils was made for a very interesting class. So maybe you don't want to bring out a bunch of glue and having kids put a bunch of glue next to each other. They might try to overglue and glue them too close together, but really they should be like spaced out. So we're just going to cut some different sizes here. And so you can imagine gluing them. Oops, that one's a little long. And making them spread out a little bit so they get smaller and smaller and smaller so they can feel the sound with the yarn. Or you could go a different approach, similar to how Scratch was showing it. Let me bring up the Scratch one again. Similar to how Scratch was showing it, where you just do the outline. You would just glue the outline of the waveform. And different waveforms, let's bring the other one up. Different waveforms might be a little different. So that one wasn't very exciting because it just had one real sound that reduced through time. So this one might be a little bit more interesting because they have to glue around the edge to do the outline. But there's, like they would have to glue, let me just get my puff paint out here. You could even just use puff paint. I'm using puff paint as glue right now, so I don't have to go look for my glue. But they could just use puff paint and make them colorful, or you can use glue there and glue the outlines like that. Or again, you could do the inside. I wouldn't do both. That's a lot of glue and it's never going to dry. As a teacher, you probably know that. But there's different ways to make your wall of sound with yarn and glue and puff paint. Let's go back to our presentation. Last week I forgot to go over the part of the presentation. I skipped like 4 slides at the end. I was running along and I looked at the time, I was like, I must be done, but then I had 4 more slides, and so I don't want to do that again. So let's make sure I get everything. Oop, there we go. Okay. All right. So you can create a sound, or you can print out some sound. You could even print out some sounds ahead of time. By the way, you don't have to have kids generate sounds. You can print out sounds ahead of time, be like, here's the different sounds we're going to use, and give each kid or a group of kids a different sound. And so maybe you have like 10 sounds that you're going to use in Scratch, and they can decorate them that way to create their wall of sound. There's different ways to go about this, but I know that the process of generating a sound, exporting the image, modifying the image so that it scales high, so it's got nice big amplitude for the kids to work with. I know that is a lot to do in a class, and you're never going to be able to talk even a 3rd grader. Maybe you could do a 3rd grader, but you're going to have trouble talking 1st and 2nd graders through how to do it. Plus, chances are you're going to have a laptop out. So there's a lot of stuff happening there. I wouldn't try to squeeze that all into one class, and a little prep beforehand where perhaps you pick some sounds that they're going to decorate for their wall of sound, or they generate a sound and they save the files and then you do the rest, would definitely be, I would recommend that. Or if you're doing this in a club with like a small group of kids, I know some teachers have mentioned that, then that's actually a better chance because you can be working with a small group of kids to teach them about saving files and file formats and stuff like that, which I think is helpful skills for kids to have. But you do you. Okay, so we've got some other extensions. Magic rocks. We talked about magic rocks last week with silicon, and how silicon pumping electricity through it, basically powers all of our modern world. Another magic rock. Now we have piezo elements. So there, you can talk more about that. Another element, not an element, it's a material. But there's a video here it's animated, but sort of like the animated for adults really, but a 4th or 5th grader can watch this and understand what's happening. It's only like 4 or 5 minutes, and it shows the structures of the crystal and why it works and how it works. And it's a great animated explanation of the piezoelectric effect. If you want to talk more about magic rocks in your classes. I talked about listening to trees. I have 2 more videos about listening to trees. And this is more of a meditative experience, I would say. If you have access to a park, I know a lot of the classes I'm teaching in now have been doing weekly walks to parks. And so you could just have the kids listen to sounds or record sounds outside. Try to be the tree, maybe. It's a bit more meditative, I think, but getting kids to actively listen and just sit still and listen to what's happening around them. But these videos show you the one, what do plants sound like, uses electrodes. The other one, sounds from trees, uses, I believe it's an electrode type thing, but it doesn't look like a normal electrode. It's a metal rod that goes into the tree to listen to it. But I think it's still using electrode type stuff, but I might be wrong. One, and the what do plants sound like is an artist / scientist talking about her process, and the sounds from trees is just the sounds from trees. But you can talk more about listening to trees. We often don't think plants is alive like we do bugs and animals. And plants can respond in their own ways. I think as teachers we should be talking more about all of living things and how they respond and how we can conserve our environment. So this is a great tie-in to the environmental crisis that we're all in. Do I have any more here? Oh, I have more resources. Oh, here's another. I already showed you this video. That video is from a Washington Post link, so you can read that link and digest the information a bit more. So I always forget I have more slides. So you can read that link. I forget how old it is, but we saw part of the video, and that will give you more background if you want to explore this and talk about it more with kids. Or it's even just good to have that information in case it comes up with kids. All right, more extra resources. I have 2 podcasts from a podcast 20,000 hertz. Hertz is a unit of measurement for sound waves, or for waves, frequency. So this podcast, it's all about sound. But the 2 I want to send you to is one is called 8-bit, which talks about how 8-bit audio was created, basically how Nintendo games made their sounds back in the day. It's a great podcast that talks about recreating those sounds. It's basically about synthesizers and a bit of history and how those sounds were captured and how they're trying to recreate them. And it's a lot about sampling. So if you do any talks about sampling or talk about music in the class, sampling is how sounds were created back in the 80s and 90s for video games too. And they would sample them, and then they'd have to compress them a bit, so that because again we talked about how cartridges were so small, they had to compress those samples that they were doing those recordings and just get little things that sort of sounded similar to it. Once you compress it, it kind of reduces the quality of the audio. So that episode of the podcast talks about sampling. And then Videoless Games is a great episode, which opened up a whole world I didn't know about people with vision disorders. They can't see games. Maybe they're blind. Maybe they just can't see clearly. I'm colorblind, so when I remember not liking first-person shooters in the 90s and the 2000s because they were always red and green, and I could never tell who was on my side because I'm red-green colorblind, and I just shoot everybody. And That's just a very minor problem. Now games are have a lot of accessibility in them where you can change those kinds of colors so that the reds and greens aren't red and green anymore, and so people like me can play them. But this talks more about how sound and immersive sound and 3D spatial audio is being used in games for people who have vision problems so that they can experience the games better. It's very fascinating, and I'd highly recommend it especially if you work with kids who have some visual impairment, because it'll help open up some ideas on how games could be more useful for them, or more entertaining for them. But it's a really great podcast. There's also the Make Code Microbit Simulator. If you use microbits, you're probably familiar with the simulator. Kind of running out of time again, but let me pop this open really quick. New project. Sound test. We're going to go to music. And so you can use the simulator here to create some sounds. It should be playing sounds now. I can't hear, but it should be playing a sound right now. All right, let's stop. That's going to be annoying for everybody. Okay. Oops. So we've got the Make Code Microbit Simulator. If you want to just do some simulated sound making there, you can run that completely in the browser if you don't even have microbits. It's a great way to make sounds. The Chrome Music Lab has these experiments that all involve sound. I like this one because it talks about oscillators, and it shows you square wave type, which we were talking about, and it's showing you the frequency value as you click and hold it, the frequency goes up. So it's got sawtooth. So it shows you how the generated wave type affects the sound. And we've got triangle waves. So you could use this as an extension just to teach kids about different wave types. We've got sine wave. And that's all of them. Whoops. That's probably really loud, sorry. Sorry about that. But there's other sound experiments in here you can use. We already went over the virtual oscilloscope at the beginning. We went over chiptune, and then we went over the generator. So that's the lesson. Sound is a tricky subject to do activities for because it's hard to do. So I hope the yarn activity, you get a good idea of how that could work. The yarn thing we were working on earlier, and hopefully chiptune works for you if you're having older students and you want to get some new sounds into Scratch. There's lots of other sound generator tools out there, but I think chiptune is like the most playful, if not a little too advanced for kids, but who cares if they don't know what everything happening is there. It's fun to click buttons and make cool sounds and just experiment. So let me know if you have any other questions. All the resources should be uploaded to the shared drive.